Today our topic is the second unit of 10th class CBSE mathematics, and the title here is polynomials. And let us understand what we exactly mean by polynomials, and let us see what we have in this lesson. Okay, and when you have say an expression like this, this is called an algebraic expression because you got some variables and some constants, and whatever you state, if it is written there, it becomes an expression. And particularly when you have some variables there, it is called algebraic expression. Okay, and when you see these two are separated by a plus sign, so you call them terms. When you have two terms in this expression, generally you call it, okay, it's a binomial. Okay, and two terms binomial when there is only a single term, of course, like this, and this is a single term, so this is a monomial. And as there are two terms, of course, you call it a binomial. And when you have three terms, like say 7x square minus 5x plus 6, you can call it a trinomial, or in general all these are polynomials. All are polynomials. Even a monomial is a polynomial. Every monomial is a polynomial, but you can't say every polynomial is a monomial, because a polynomial has got any number of terms, of course, either 1, 2 or 3, whatever it is, there are terms. But there is a small clarification here. Whatever expression you are given, an algebraic expression, can you call it a polynomial? So the answer is a clear no, because a polynomial is precisely an algebraic expression in all the cases, but all algebraic expressions, you don't call them polynomials. I just give you one example for this. Say if you write 3x square plus 6x minus something like 4 upon x. So this is not a polynomial. If you find a variable in the denominator, it is an algebraic expression, sure about it, but it's not a polynomial. So here, this is not a polynomial. And you can call it an algebraic expression. So all algebraic expressions are not polynomials, for the reason, if you have a variable in the denominator for some value of x, it becomes undefined. Okay, so if x equals 0 here, we don't know the value of this polynomial, algebraic expression, so it is not a polynomial. So a simple an acid test here is, if there is a variable like x in the denominator, don't call it a polynomial. It is an algebraic expression for sure. And similarly, if you have say x square plus 3x plus 5, suppose there is a variable in the denominator. Okay, as long as if you have a number, there is no problem, but there is a variable in the denominator, so this is also an algebraic expression, and but it is not a polynomial. Okay, and this is not a polynomial. So these two cases, when you observe, as a variable is found in the denominator, they remain algebraic expressions, but we don't call them polynomials. Okay, if that part is sure, I just go back once again. Okay, and I just take out these two which are not polynomials, and let us understand this one. You have got some polynomials here, either carrying only one term or two terms or whatever it is. When you look at this one, the highest index found is 2. Okay, so this is 2, and therefore this polynomial is called a quadratic polynomial. Second degree polynomials have another name. Okay, we call them quadratic polynomials. Precisely trinomial, of course, there are three terms, but remember, this is a quadratic polynomial. quadratic polynomial. And here the degree of this 2x plus 3, the highest index is x raised to power of 1. Actually 1 is not written. So this is a first degree one. Okay, and first degree one, when you have, you call it a linear polynomial. Okay, first degree ones are called linear polynomials. And if you look at this one, this is a third degree one because the index here is 3. This is the third degree one. So this is cubic polynomial. So first degree polynomials are called linear polynomials, and second degree polynomials are called quadratic polynomials, and third degree cubic, and later you also have quartic, quintic, and so on. We don't need them actually. So we are talking about quadratic polynomials where, you know, like you have some x squares and some x and some c. Okay, but make sure that a is not equal to 0, because if you want to say it's a quadratic polynomial, this second degree term must be present. So I just write here to be on the safe side, my a is not equal to 0, and this is the standard form of a quadratic polynomial. Standard form of a quadratic polynomial. Okay, so the standard form of a quadratic polynomial here is ax square plus bx plus c. Remember one thing, of course, you don't write is equal to 0 because that becomes an equation. Polynomial is an expression, that's it. It is not an equation. You will not find is equal to sign anywhere when you write a polynomial. Okay, so you don't equate this to that's completely different. Okay, and you must be pretty sure that when you're writing a polynomial, it's just an expression. It is not a statement. It is incomplete. Doesn't make a complete sense there. It is just an expression, and which is not an equation. Equation is a sentence. It is a statement. You are saying that E is equal to something, and so when you write a polynomial precisely, something you should remember is that you will never find is equal to sign anywhere. Okay, that is a quadratic polynomial. Quadratic polynomial is of, say, second degree. Okay, you should start with some x squares. Okay, and then you may have x or you may have constant or not, that's immaterial. So the highest degree that you find there in the algebraic expression is 2. Okay, let me just say we have about, this is something very interesting part here about zeros of a polynomial. Okay, well, let us understand what we exactly mean by the zeros of a polynomial. And I just want to clear some point here. Say this is a quadratic polynomial. Okay, quadratic polynomial. But if you write ax square plus bx plus c is equal to 0, this is a quadratic equation. Okay, you must know the difference between, this is a sentence because there is a verb here, is equal to. Okay, so this is a statement. I mean, this is not a statement, this is an expression. So this is a quadratic polynomial. And whereas that one is a quadratic equation. You should not get confused between these two. Quadratic equation. Okay, then there is another thing that differentiates this and this one. When you are given like this, you solve it to find the value of x. Okay, so can be solved. And when you solve this quadratic equation, what you get, the values of roots you will get. Roots means value of x, or value or values of x. We call them roots. Whereas here, okay, what value of x makes this polynomial 0? That's what we can find out. So we have zeros of the polynomial. Zeros means for what value of x the polynomial becomes 0. For what value of x the polynomial becomes 0 or equals 0, becomes. So the essential part that should be remembered here is a polynomial has zeros, an equation has roots. Equation can be solved, polynomial we don't solve it actually. Okay, that is what you should understand, because if you have an equation you can solve it, determine the value of x, but this is not an equation, this is an expression. So a polynomial is all the time an expression, and therefore it can be solved. I can't find the value of x, but I can say one thing, for what value of x that polynomial can become 0. So now my point here is, if I have a polynomial which can be factored, remember this word, which can be factored and written in the form of x minus alpha and x minus beta, if you can write like this, if a quadratic polynomial, it's a second degree one, you get two first degree factors. So it can be factored. Okay, means factorization is done. This can be 0 if x is alpha. Alpha minus alpha is 0. 0 times something is 0. So in place of x, if you write beta also, it can be 0. Beta minus beta is 0. 0 times something is 0. So when x assumes the value of alpha or beta, you get zeros, because the whole thing becomes 0, because this is a quadratic polynomial which is just factored, and therefore zeros here, zeros are alpha and beta. Means for these two values, you can't have more than that, of course, because the degree is only 2. Essentially, you have only 2 zeros. Sometimes it's only 1. Okay, so that's what you should remember. So for when x takes the value of either alpha or beta, and you are going to get 0 if you substitute here. Therefore, this has got only 2 zeros, alpha and beta. And how do you know that this is a quadratic polynomial? When you multiply these two, what is the form? X times x is x square minus alpha x and minus beta x. So minus alpha plus beta times x, and product of these two is alpha beta. So this expression is equal to this one. And when you look at this form, you can say that alpha and beta are the zeros of that polynomial. Once again, if this is the polynomial given to you, quadratic polynomial, because this is a second degree one, and this is the quadratic polynomial we are considering, quadratic polynomial. And this quadratic polynomial is factored like this, factored like this. These are the two factors. And when you look at the factors, you can find out the value of, the zeros of the polynomial. So there are two zeros here, alpha and beta. So let us do a small problem. Suppose I have x square minus 5x plus 6. This is a quadratic polynomial. And let us factor this. Okay, let us factor this or factorize this by splitting the middle term. Okay, so if you don't have here any coefficient, just say this is 1. This is 1x square. You call it a monic polynomial. Don't bother about it. This is 1x square. 1 times 6. You write here 6. Means the product is equal to 6. Product is equal to 6. And I repeat, this is 1 and this is 6. You have to multiply these two, write here 6. And the middle term, whatever you have, that is the sum. Sum is minus 5. Now you have to guess two numbers in such a way. The sum is minus 5 and the product is 6. Okay. So now what are those terms? You can write minus 2 and minus 3. because if you multiply you get 6. If you add these two, minus 2 and minus 3, when you add you get minus 5. So if you can guess these two by intuition, okay, we don't want you, like it's just a guess, it's an imagination. Okay, so now I split this middle term as this and this. I separate them. So I have x square minus 2x minus 3x plus 6. This is an expression and this is an expression. So in between you can put is equal to. And remember one thing, between a statement and another statement you put implies. And between an expression and another expression you put is equal to. Fine, leave it there. So the first here, in these two terms, I can take out x as a common factor because this is x times x, this is 2 times x. So if x is taken out as a common factor, x times x is x square, x times minus 2, x times minus 2 is minus 2x. So x times x minus 2. So now in these two what can be taken out, because 3 1s and 3 2s I have here, and there is a minus sign also here. So I take minus 3 as a common factor, minus 3 times x, minus 3 times x minus 3x, minus 3 times minus 2, minus 3 times minus 2 is plus 6. Now if you look at this part, you understand that x minus 2 is again a common factor. So I take out x minus 2 here as a common factor, and this x is left here, this minus 3 is left here. So this is a quadratic polynomial. We have written as that as the product of two first degree polynomials. Okay, and now you can tell me the zeros, because this becomes 0 if x is 2 and this becomes 0 if x is 3, and therefore zeros I can find out, zeros of the given polynomial. The zeros of the given polynomial, there are two zeros, 2 and 3. So if you want to find out the zeros of the polynomial, the procedure we adopt here is that we just factor it, we factorize it, and we get that as a product of two linear polynomials, and each of them of course equated to 0, find the value of x, and that's how you get the zeros. Like if this has to become 0, x must be 2, and if this has to become 0, and x must be 3. Therefore there are two zeros for a quadratic polynomial. All the time, not necessary that you should have 2. Okay, that should be considered very seriously here. I'll give you now one polynomial where like you don't have two zeros, though it is a quadratic polynomial, you have only one. Okay, let us see a case. I give you another polynomial where you don't have two zeros. Okay, you get only one. So let me take an expression like x square minus 6x plus 9. This is the quadratic polynomial given to me. So what I should do now is, okay, this can be equated to, and this is 1 and this is 9. So 1 times 9 is 9. So product must be 9. Product must be 9. Okay, and this middle term, the coefficient of x you have here minus 6, and that must be the sum. Sum is equal to minus 6. Now you have to think of two numbers where the sum is minus 6 and product is 9. So I get easily minus 3 and minus 3, because if I add them I get minus 6, and if I multiply these two my product is 9 there. So the middle term is split like this. So instead of minus 6x I write minus 3x and minus 3x plus 9, and x is a common factor in the first two terms, x times x minus 3, and in these two again minus 3 is a common factor, x minus 3, and x minus 3 is a common factor now, and leaving behind here x and here minus 3. So if you look at this form, what you understand is the zeros are 3 and 3. You can't write 3 two times, of course, not required. Redundancy you call it. So it's only 1 3. So how many zeros you have here is equal to is only 3. Only 1. You just write zeros. Okay. So you have only 1 0. That's what is interesting actually. So you can say 0 or zeros. It's only 3. So the point to be noted here is when you are given a quadratic polynomial, there can be a case where you have got two zeros. There is a case where you have only one zero. But in all the cases, it is not possible. There can be a polynomial where there are no zeros at all. And that can be understood actually, okay, graphically. That makes our work much easier. So now if I try to draw the graph of a quadratic polynomial, usually I get a parabola. Okay, and let me look at different cases of this parabola. So this is my x-axis and this is my y-axis, and if I get a parabola like this parabola is meeting x-axis, means y coordinate is 0, meeting x-axis at two different points. It is meeting x-axis here, it is meeting x-axis here also. So when I write the coordinates of this point or this point, how do I get? I just get some a and 0. So I get some, say, b and 0 here. So for two values of, on x like a and b, the y becomes 0 because the x-axis, the point y coordinate is 0. This is also an x-axis, y coordinate is 0. Okay, so there are two zeros for this polynomial. But I need not have the parabola all the time like that. There can be a case, okay, and I tried to draw the parabola and I got a parabola like this. And what does it mean? It is meeting the x-axis at only one point. I don't have two zeros. So for such graphs, it is only 1 0. That polynomial has got only 1 0. And here the polynomial has got two zeros. So the question obviously comes, how does a parabola look like when there is no zero for that? It doesn't meet the x-axis. So easily I can say if my graph is, okay, if my graph goes like this, if this is the parabola, this parabola is not meeting the x-axis, of course, and therefore if I try to find the zeros of such quadratic polynomials, I don't get any zeros. Means for no value of x, the polynomial becomes 0. So that case, I write there are no zeros. Okay, so obviously you should understand there are three different cases. You can have a maximum of 2. It can be only 1 0, or there may be a case where there are no zeros at all. So this is what should be, studied graphically. And I can give you another parabola. Like suppose I give you a parabola like this. It can be an inverted parabola if the x square coefficient is negative or whatever it is, Suppose I give like this. Then also you can say there are two zeros. There are two zeros there because it's meeting the x-axis at two different points. So depending on at how many points the graph is meeting x-axis, you can determine the number of zeros. It can be 2 zeros or 1 0, or it can be no zeros at all. But now let me take another case. What if the polynomial taken is a third degree one? Okay, I can expect a maximum of 3 zeros. I repeat this point. I am taking a cubic polynomial. It's a third degree one. Because it is a third degree one, I can have 3 zeros. That's a maximum. Means there is a possibility of that curve meeting the x-axis at 3 different points. Okay, so let me just look. This is my x-axis. This is not a quadratic polynomial. You should remember that. Okay, it's meeting here, it's meeting here, and it's meeting here also. So if you look at this, polynomial drawn, graphically represented, on a graph paper, you will understand that polynomial is meeting x-axis at 3 different points. Okay, and therefore, how many zeros can you expect? 3 zeros you can expect. Okay, and you can't say that, no sir, what happens if it comes down? the polynomial would be different. If it meets at 4 points and the degree becomes 4, it becomes a 4th degree polynomial. But I am giving you only 3rd degree polynomial, and therefore there is no chance of getting more than 3 zeros. So this is a cubic polynomial, representation of a cubic polynomial, and you have a maximum of say 3 zeros. So every polynomial has got zeros. Zeros means the value of x which makes the polynomial 0. Okay, and a cubic polynomial has a maximum of 3. A quadratic polynomial has got maximum 2 zeros. If it is a linear one, it's only 1. Okay, and that's what you should understand about the number of zeros you can expect. And 2.1, you have several graphs, and you just have to take that. Okay, and you just have to identify the number of zeros there. I move to a simple topic here. What's the relation between the coefficients of x square, x and constant there with that of zeros? So we study that relationship actually. Like, let us say there is a quadratic polynomial like this, and condition a can be 0. See, a quadratic polynomial we have considered. Now, when a quadratic polynomial is given, when you start factorizing that, let us say I have got a numeric factor, because there is a number which is common in all of them. So let us say I take k as a numeric factor, because all these have got a number in common. 2 is common, 3 is common, it can be. So this is a numeric factor. It's possible. So the other two factors are first degree ones, x minus alpha and x minus beta. So this is what happened actually. I am given a quadratic polynomial along with the 2 first degree polynomial, because this is second degree. I have 2 first degree polynomials. Along with that, of course, there can be a numeric factor, of course, which you can't ignore that. Of course, this is a numeric factor. Now I multiply these 3, I should get this one, because I factored this, I got this. And if I multiply these 3, I must get that. Okay, and then I start comparing the coefficients to, find if there is any relation between alpha plus beta and alpha beta with a, b, and c, of course. So let us now work out. Now k times, when I multiply these two, what do I get? X square. Okay, I just take it like x square and minus alpha x minus beta into this x, and when you multiply these two, you get plus alpha beta. Let me write in a better form, consolidating these x coefficients. X square minus, I write x also out, I have alpha plus beta, minus x times alpha minus x times beta. Okay, and this is alpha beta. So if this is what we got when we multiply, the factors what we got, I can compare now this and this can be compared. Now k times x square I have, because I just write one more step to make this easier for you. Kx square, k times this minus k times alpha plus beta times x, k times alpha beta. That makes the things a little easier for you. Now this is what I have to take now for the comparison sake, a, and this is k. So I write a equals k. Next one, bx and minus k times alpha plus beta x. Okay, minus k times alpha plus beta, x coefficient minus k times alpha plus beta, but x coefficient is b, is equal to b. Next one, k times alpha beta, this is c. So k times alpha beta is equal to C. So now it is easy for me to compare. See, because K value is A here, because K can be replaced by A. That's what I do here. Minus, I want only in terms of A, B and C. That's it. Any other variable I don't want, like. K means A. Alpha plus beta is equal to B. And therefore, alpha plus beta is equal to, I transfer this minus to that side, minus B by A. Now tell me here, in place of K I can write A, alpha beta is equal to C, and alpha beta is equal to C by A. So my conclusion here is quite simple. Sum of the zeros is minus B by A, and product of the zeros is C by A. That's what we got here. I just write here, sum of the zeros, I got a formula for that, and product of the zeros, I got a formula for that, and this is minus B by A, and this is product is C by A. So obviously, it is not an overstatement. When you are given a quadratic polynomial, you can find out the sum and product of the zeros without actually factoring. By looking at the coefficients, you can guess. Okay, minus B by A gives you the sum of the zeros, and C by A gives you the product of the zeros, but you don't know the individual zeros because you haven't factored it. So quadratic polynomial, you are not treating it, okay, you are not trying to factorize that. But without even factorizing, you can talk about the sum of the zeros and product of the zeros. We have derived a formula for sum of the zeros, minus B by A, and product of the zeros, C by A, and without factorizing that. So when you are given a quadratic polynomial, you should understand, to determine the sum of the zeros and product of the zeros, you don't need to find the zeros. Okay, you don't need to find the zeros, but still you can tell the sum of the zeros and product of the zeros. Okay, having said that, of course, we have a few examples to do there. 2.2, just two problems are there, and I do. You are given a quadratic polynomial. Find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficient. Find the zeros, that is what is important actually, like. And you also find out the sum and product of the polynomials, and you just establish a relation between them. I take, say, one polynomial given here is x square, my first problem, x square minus 2x minus 8 is given. This is the quadratic polynomial. How do I factorize that? This is 1, so don't worry about it. 1 time this minus 8 is minus 8. So I need product to be minus 8. And sum must be minus 2. So I have to find out two numbers, of course, in such a way. If I multiply, I must get this. And if I add, I must get this. So easily I can say minus 4 and plus 2. Because if I multiply these two, I get minus 8, and minus 4 and plus 2, the sum, the result is minus 2. Okay, 4 I need to give, and I have only 2. So the result is I need to give 2 more, okay, minus 2. So I split the middle term. X square minus 2x is replaced by this and this. Minus 4x plus 2x, and I write minus 8. And x times x minus 4, and in these two, 2 is a common factor, 2 1s, 2 4s, plus 2 times x minus 4, and eventually I have x minus 4 times x plus 2. And remember, this is plus 4, zeros you are trying to find out, okay, zeros. This becomes 0 when you have in place of x when you write 4, and this becomes 0 when you take in place of x minus 2. Zeros are written there. Okay, fine. Having done this, of course, don't think this and this are same. That is, we use it for factoring. Okay, these are the zeros. Now, how do we get the sum of the zeros? We have a formula for that, minus b by a. Minus of b is minus 2 by a is 1. So that is minus of minus is plus 2 you got. This is sum of the zeros. Now you want the product of the zeros. The formula we have written there is c by a. C by a minus 8 by 1. That is minus 8. Now let us just check. Zeros 4 and minus 2 when you have, if you add them, 4 and minus 2 is plus 2. And the product of zeros 4 times minus 2 is minus 8. So what is that we have done? We are given a polynomial. We have factorized that, and this part is not important for us, of course, for the process we have done, but for splitting the middle term. And we completed the process of factoring, and you got zeros and verification. Sum of the zeros, use the formula and find out. Product of the factors, use the formula and find out, and that should match with the zeros you've got there, because this is alpha and one of them is alpha and one of them is beta. So you are given a polynomial, you have to factorize that, determine the zeros, leave it there. And you also can find out the sum of the zeros and product of the zeros using the formula and check if these two match or not. Okay, and there is one problem here, is an interesting one. I just take 4a square plus 8a. Okay, 4a square plus 8a, and you have to find out the zeros and find out the sum and product. I just take the next problem. I am given 4a square plus 8a. This is a very simple question. And for one reason, this is a quadratic polynomial. I can take out 4 as a common factor in both the terms. That's a numeric factor. A also can be taken out as a common factor. No splitting middle term, nothing. There is no constant there. 4a times a, 4a square. 4a times 2, 8a. 4a times 2 is 8a. So now, can you see 3 factors here? That's the question. Say this is a numeric factor, and these two are the other 2 factors, a and a plus 2. So looking at a, you can say that a can be 0. So 0 of the polynomial is zeros. It can be 0. Means if a value is 0, the whole thing becomes 0. 4 times 0 times something becomes 0. So where else does it become? This can be 0. So in place of a, you can write minus 2 also, because minus 2 plus 2 becomes 0. So there is minus 2. So you got 2 zeros. Only thing that has happened here is, because there is no constant here, you have factored it directly, because there is no splitting the middle term and all that. Straight away you have got 2 zeros you got. Now let us understand. Now sum of the zeros is equal to, minus b by a. There is no constant here, remember that. Minus 8 by 4. Does it work out here? Minus 2. Yes, of course, if you add these two, you get minus 2. Then, product of zeros. Product of the zeros. Let us understand c by a. That is a formula. 0 by 4 is equal to 0. Of course, if you multiply these two, you get 0. So we have verified. We have taken the given quadratic polynomial, we have factored it, we got zeros, and from the formula we got sum of the zeros and product of the zeros. We just verified if the values what we got for zeros do match with that one. My next problem and last problem is, this is very simple one. Find a quadratic polynomial each with the sum of the and product of the zeros respectively. Okay, and I just can orally give the answer for that, and let us see. If you are given, okay, alpha and beta, okay, are zeros, how do you write the quadratic polynomial? That's it, x minus alpha times x minus beta. So this is the polynomial. If you are given the zeros, this is the polynomial. Okay, and if you multiply these two, that's the polynomial you want. X square, okay, minus alpha x minus beta x minus alpha plus beta x, and product of these two is plus alpha beta. As simple as that. Now he is giving that sum as root 2 and product as 1 on 3, like, you know, that's it. He is telling sum of zeros you are given is equal to root 2 and product is 1/3. Product is equal to 1 on 3. Now sum of zeros means alpha plus beta, product of zeros is alpha beta, and write in this one. That's it. You got your polynomial. Polynomial is x square minus, okay, in place of alpha plus beta you can write root 2x and plus product. This is 1 on 3 actually, plus 1 on 3. That's it. This is the answer. So you are given the sum and the product of the zeros. Sum of the zeros means you are given alpha plus beta. Product of the zeros you are given alpha and beta. And that's it. You substitute, because this is the polynomial, of course, where the zeros are alpha and beta. That is exercise 2.2. Okay. If that is done, then you have in 2.3 some simple division problems. Okay, if one polynomial must be divided by another polynomial, you need to determine the quotient and remainder. Okay, you can do the division. I just show you one division. Okay, and my next problem from 2.3, and one polynomial has to be divided by another polynomial. And one polynomial is given as p of x. This is exercise 2.3. P of x is equal to, you are given x cube minus 3x square plus 5x minus 3. This is one polynomial. And there is another polynomial, of course, g of x, x square minus 2. And he is asking, when divide the polynomial p of x by the polynomial g of x and find the quotient and the remainder. Okay, it's a very, very simple one. And now don't get confused when you are given such a notation such as p of x. P is the name of the polynomial. Of x means something which depends on x. When you say f of x, you say function of x. Function of x means an expression which depends on x. That's it. Suppose you have volume of a sphere. You learnt last year. I write 4/3 pi r cube. That's the formula for that. 4/3 pi r cube. There is only one variable r. So volume is a function of r. Means if I know the radius, I can find out the volume. Means volume depends on the radius. So we also write it as it is a function of r. Don't get confused. If r is given, you can find out v, volume. Another way I want to tell you, r is the radius. Okay, you say it's a variable. And v is the volume. You say it's a value. So if you know the variable, you can find the value. If you know the value of x, you can find the value of y. As simple as that. Come on, get ready. So I need to do the division. It's a long division. X cube minus 3x square plus 5x minus 3. And it should be divided by x square minus 2. Now, in this x cube, x square goes how many times? Like x cube divided by x square? X times. Okay, x times x square becomes x cube. So I write here x. Now x times x square is x cube and x times minus 2 is minus 2x. I don't want to write under this one because this is x square term. X times minus 2 is minus 2x. I write here x under x. What do I do now? I subtract. Okay, when I subtract, I change the sign of this coefficient. It becomes minus x cube gets cancelled. And this minus 2 becomes plus. And plus 5 plus 2, and that becomes 7x. And I didn't use this one. I just want to bring it down now. Minus 3x square. And this is of course plus 7x. The next step, of course, in this minus 3x square goes how many times? Minus 3x square may x square minus 3 times. If you can't do that, you can write here minus 3x square may, in this x square goes how many times? Minus 3 times. So I am writing minus 3 here. Minus 3 times x square minus 3x square. And minus 3 times minus 2. Plus 6. Minus 3 times minus 2 plus 6. I repeat, minus 3 times minus 2 plus 6. I don't want to write it under x actually. Now again subtraction. When you change the sign, plus 3x square and earlier minus 3x square, you can strike it off. From 7x you are not subtracting anything, so 7x. And I change the sign of this one because this should need to be subtracted. From this I should subtract this, minus 6. The question obviously comes, is this a division over or not? I say the division is over. Why? Because this is a second degree one and the remainder is a first degree one. You need not go any further. Okay. So the moment you get the degree of the remainder less than that of the divisor there, the division comes to an end. So you can stop here. So this is the division. He is giving you two polynomials. Don't think that it is an equation. This is not an equation. The name of the polynomial is p of x. It's p actually. The name of the polynomial is p. Okay, for the convenience sake, instead of writing the whole thing, he said p. But p is depending on x. So he said p of x. Similarly, this is g of x. He is asking divide p of x by g of x. That's what we have done. Okay, and when do you stop this division? This is a long division, and the moment your degree of that remainder is less than that of the divisor, you can stop. And there is one more problem, of course, which is slightly different, and second bit is the same, dividing the first polynomial by the second polynomial. That's very easy. And third problem, obtain all the other zeros. You are given a polynomial there, of course, at the fourth degree. Two of the zeros are given. Okay, that's the last problem I try here. That's it. Okay, and I am given a fourth degree polynomial. This is question number 3. 3x power 4 and plus 6x cube minus 2x square minus 10x and minus 5. And you are given that there are two zeros here, root over 5 on 3 and minus root over 5 on 3. Okay, so this is a, like a simple proposition and nothing much actually like. This is the fourth degree polynomial. Okay, so you should have 4 zeros, a maximum. Okay, you are already given 2 of them. And how many more can you have? Maybe another 2. So what is that I should do is, with these 2 zeros, I create a polynomial. Okay, with these 2 zeros, I create a polynomial. And if this polynomial is divided by that polynomial, I get the product of the other 2 polynomials. I mean, other 2 factors. Like, let us just work out. So now x value can be this, because he has said that is a 0. And x value can be this, minus root over 5 by 3. So squaring on both sides, I get x square equals, I do one thing, root 3 times x, root 3x is equal to root 5. And here root 3 times x is equal to minus root 5. And this, if I bring root 5 this side, root 3 times x minus root 5 can be 0. And root 3x, bring that this side, plus root 5 can be 0. Keeping this here, if I multiply these two, I must get a 0. And I am writing polynomial here, not an equation. Polynomial. This multiplied by this, root 3x minus root 5 multiplied by root 3x plus root 5. And come on, 3x squared minus root 5, a minus b in times a plus b, a square, square of this is this, square of this is 5. So now I have got a second degree polynomial which must be a factor of this one. Okay, so what I can do now is, I am given two zeros. I have found a polynomial which has got these two zeros, and this is divided by this one so that I get the product of two more factors actually. It's a very simple division, 3x power 4 plus 6x cube minus 2x square minus 10x minus 5, and must be divided by 3x square minus 5. 3x square minus 5. Start your division. 3x power 4 divided by 3x square. It is simply x square. I write x square here. X square times 3x square, 3x power 4. X square times minus 5, minus 5x square. X square under x square. Subtract. This gets cancelled. From this you are not subtracting anything. Write down 6x cube. From this you are subtracting this one. This becomes plus 5 and minus 2 plus 3x square. Bring down maybe minus 10x. My next step here. In this 6x cube, 3x square goes how many times? In this 6x cube, 3x square, 2x times. So I write here 2x. 2x times 3x square, 6x cube. 2x times minus 5, minus 10x. 2x times minus 5. Subtraction. And this gets cancelled here. From this you are not taking anything out. 3x square. This becomes plus, gets cancelled. And bring down this minus 5. My last step. In this 3x square goes only one time. So if I write here 1 time 3x square, and 1 time this minus 5 is minus 5. Obviously I got 0 as the remainder. My division is done. So now the problem becomes like this, that you write down 3x power 4, 6x cube, minus 2x square, minus 10x, minus 5. From these zeros you got this product, mean 3x square minus 5. And what is the quotient you got here? X square plus 2x plus 1. Understand, if you resolve this one, you get these two zeros, but there is something more here. And this, by observation, you can say this is x plus 1 whole square. So I have x minus, this is root 5 over 3. And this is x plus root 5 over 3. The product is this. And here you have x plus 1 times x plus 1. This is in the form of a plus b whole square. I have resolved that into two factors, x plus 1 and x plus 1. So from this you know that 0 is minus 1. From this you know that 0 is minus 1. That's it. So I have got one more 0. So I just write here my answer. So what are the zeros? Other zeros are, minus 1, minus 1. You need not write both. Other 0 is minus 1. Okay. So this is the problem you got. You are given a quadratic polynomial. And there's a fourth degree one. Okay. Fourth degree polynomial, not a quadratic polynomial, fourth degree polynomial. We can generally, it's a quartic polynomial. Okay, fourth degree one. Quintic is fifth degree. Fine. Fourth degree polynomial shall have 4 zeros. He mentioned only 2 of them. He just asked, find out the other zeros. So we found that like this is the product of from the given zeros I got this product, and this is the remaining part. So from there I found that there is another 0, that's just -1. -1 it repeats, but you need not write 2 times, of course it's only -1. And this is the chapter polynomial, and it's a very easy chapter, and the important points you should remember here is that polynomial is a algebraic expression which is defined for all the values of x. All polynomials are expressions, but all expressions are not polynomials. There is a condition for an algebraic expression to become a polynomial. Second thing is that we wanted to find out the zeros of the polynomial. Graphically we said at how many points, of course it's meeting the x-axis, is going to tell you the number of zeros. Okay, and if you take a cubic polynomial, it can meet at a maximum of 3 points. You get 3 zeros. Quadratic polynomial, because it's only second degree one, you get only 2 zeros. That too its maximum. Okay, you can have no zeros, 1 zero. A quadratic polynomial has got maximum 2 zeros. And later we found a relation between the zeros, sum of the zeros and product of the zeros with the coefficients of x square, x and constant given there. If you are given ax square plus bx plus c, where a is not equal to 0 is the given polynomial, sum of the zeros alpha plus beta is the same as minus b by a, and product of the zeros alpha beta is the same as c by a. Thank you very much.